Hi, I saw this problem. I thought I'd help you real quick on it. This will be solved by the comparison test. Okay, first thing that you have to show is that you've got two series. Let's say we have the sum of the series of a sub n and the sum of a series b sub n. Okay, this series here would be our a sub n. So we'll say our a sub is 1 over n times n plus 1. And then this is going to infinity, as we know. 1, 2, 3. Our b sub n would be similar to this, except it would just be 1 over n squared. N times n is n squared. So I'm comparing it to 1 over n squared. The first thing that we have to show is that this is less than this. So a sub n is less than b sub n, which it is. If you plug in a 1, you're going to get 1 over 2. And that's clearly less than 1 over 1. If you plug in a 2, that's going to be less than whatever this value is. Plug in a 3, so on and so forth, that's going to be less than this value. So you can clearly see that this is less than this. Now what we're going to show is we're going to show if this series converges. Okay, b sub n converges by the p-series test. Since p is greater than 1. So we know it converges by p-series since p, the power, is greater than 1. The power is 2, so we know that this series converges. And if b sub n converges, therefore, if b sub n converges, then a sub n converges. Since a sub n is less than b sub n. Okay, so that's basically all you're showing there. And that proves your convergence. Now, the sums, you just plug in the first 4 numbers and add them together. Now, for to find the value that it converges to, right? So we're going to go ahead and find the value that it converges to. And you're going to have to do partial fractions. And I'll show you how to do that. What you're going to do is you're going to say 1 over n times n plus 1 is equal to a over n plus b over n plus 1. I'll cross multiply this n times n plus 1 to both sides. Okay, when I cross multiply it with the a, this and this are going to cancel out on this side. I'm going to get 1 equals, I'm going to get a times n plus 1 plus b times n. Okay, to solve this partial fraction, the first thing that I'm going to do is I'm going to try to cancel out this b, and I'm going to say n is equal to 0. Okay, when I do n is equal to 0, I plug in 0 for wherever there's an n. So I get 1 is equal to a times 0 plus 1 plus b times 0. So that gives me a is equal to 1, because you get 1a is equal to 1. Okay, now I'm going to do the same thing, and I'm going to say n is equal to, I want to cancel out this term right here. I'm going to say n is equal to negative 1. I'll plug in the negative 1, and I'll get 1 is equal to a times negative 1 plus 1 plus b times negative 1. And that's going to give me b is equal to negative 1. And what you're going to see is the series is like this. It's going to be 1 over n minus 1 over n plus 1. So now what I'm going to do is I'm just going to plug in 1, 2, 3, 4, so on and so forth. Whatever it starts with. You see it starts with n equals 1. I'm just going to go ahead and plug that in. I'm going to get 1 minus 1 half. Okay? Now I'm going to plug in the 2. I'm going to get plus 1 half minus 1 third. Plug in the 3, plus 1 third minus 1 fourth. What you're going to see right here is these, and eventually the 1 fourth, so on and so forth, are going to cancel out. This series converges to 1. I believe the other tutor said that, but he didn't show you the way that you actually find out that it's a telescoping series. It's got to be partial fractions, and that's how you determine if this series converges. And there we go. It converges to 1. There we go. Hope it helped. Thanks.